What would you like to talk about as far as homework? Anything? Pretty straightforward? We doing what?
Are we trying this one too?
No, like you did the last one? No. I didn't get a chance to grade those. They were on my desk, and then I had a couple of things come up. So I'll have those back for you next week. All right, well, today is the day that we finally figure out how we can use this whole division thing, and especially the synthetic division, to factor. Because that was kind of the ultimate goal, right? And we kind of talked about it at the very end of class last time, that what we're looking for is a technique that we can follow when we're looking at something we don't know how to factor, right? And I believe I had started that first one, right? Yeah, that first one right there, x cubed plus 8x squared plus x minus 42. We knew how that broke down. That's right. We made a list, right? So what I'm going to do is I'm going to move on to the next one. We're just going to start from scratch. I'm going to ask us to factor this. Now, we have a couple of options when it comes to how we can present this to you. When I say we, like faculty, we can get very technical. We can start throwing out some pretty fancy words and calling certain things certain, like this and that and blah, blah, blah. And it can get a bit confusing. To me, the process is more about you understanding what you're going to look at, what numbers you're going to focus on, and then doing something with those, rather than getting hung up on all the terms, terminology. So what we do when we want to factor something is you run through everything that you know up to this point. GCF, right? GCF. That's not GCF. That doesn't have a GCF. There are three terms, right? Yeah. So maybe it's like a quadratic, but you look at it, it doesn't quite have the form of a quadratic because it's third degree and this is first, right? So it's not going to factor like a quadratic. You can't do grouping because grouping needed four terms, right? I mean, you're pretty much hung up at this point, right? So the question is, does it factor? Well, we're going to find out. What we do first for this new method is we make sure it's in descending order. So this is in descending order, highest power of x down. And we're going to focus on two numbers. The number in front of the highest power of x, okay, the 1, and then the number back here. And it really, again, does not matter whether or not you look at the positive or negative 20. Let's just look at 20 itself, okay? And you're going to create, to start, two lists of numbers, and then from those two lists you create a final list. The first list, I always start with the number in the back. And the reason why I do that, I'll explain when we make our final list.
Because it's usually bigger?
Because this is well, just wait, yeah, just hold tight. No, because this doesn't have to be bigger than that. Take this number 20. This is my first list, which will be all the factors of 20. All factors of 20. So I list them out, plus or minus 1, and then I did this at the end of class again, I put a big gap between the two numbers, 1 and 20. I'm going to work my way in. And we always look at plus and minus, right? Because I can create 20 by doing 1 and 20 or negative 1 and negative 20. So go into the next number. How about 2? Can I multiply 2 by anything to get 20? 2 and 10. So I do positive and negative 2. I do positive and negative 10. Then how about 3? Does 3 go into 20? Not evenly, right? We could have a remainder or decimal, so we won't look at that. How about 4? 4 and 5? And that's it. As soon as we meet in the middle, we're done. So that's my first list. My second list are all the factors of 1, which is just plus or minus 1. The final list is the first list divided by the second. list. That's why I do the number in the back first. Just because these numbers are going to be on top, like out of a fraction, you're going to make a fraction out of these, right? And so these are on top of these. That's why I do this list first. Does that make sense? It's going to be like 1 over 1, 2 over this, 2. So it fits more into looking like a fraction that way. All right, so if I were to take each of these numbers, right? Like let's say I take positive 1 divided by positive 1, I get positive 1. Positive 1 over negative 1, I get negative 1. Negative 1 over positive 1, negative 1. Negative 1 over negative 1, positive 1, right? So really, the only thing you're going to get when you do this is just plus or minus 1. Then when I do 2, it's the same thing, right? Plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. So when this number here is 1, your final list is always going to be what? Your first list. Was that your question, or?
No, I'll ask it later if you don't cover it, but I think you're probably going to.
Okay.
I was just going to ask about if the number out in front was not 1. It was like
That's going to be the last example we do.
Okay.
Yep. All right, so my final list is just my first list. How many numbers are in this list? Is it 12? Right, 12 numbers. These are the candidates, right? There's 2 numbers here, 2 numbers here, 2 here, 2 here, 2 here, 2 here. So these are the candidates, 2, 4, 6, 8, 10, 12. Oh, 20, yes, I'm sorry, that's why you're looking at. Sorry, that's what you were looking at. Right? 12 numbers, right? Positive and negative 1, that's 2 numbers, positive and negative 2. Yep. Okay. These are the candidates for this polynomial that we can use in the synthetic division and hope to get what? In synthetic division, what are we hoping to get? A remainder of 0, right? If we get a remainder of 0, that means that this does factor. All right, so we just start going through our list. And I will direct you to please, on the test, always start at the smallest number and work your way up. If you do that, I told you I promised it would happen within the first, 6 tries. I'm not going to give you a problem that intentionally the only one that works is 20. You know what I'm saying?
Or there's like this list of like 20 possibilities and it's like the 14th one.
Exactly. I promise I'll keep it within the first few as long as you promise to start from the smallest and work your way up. All right?
Fair enough.
Okay, so let's do this.
It's going to be the 6th, now it's going to be the 20th. And you've got to figure out which one it is out of 40.
What goes into the synthetic division box?
It's going to be the 1, negative 21.
No, 1, then 0.
0. Be real careful with that, right?
And then the negative 21, then the negative 21.
That's right. So be real careful with that 0. That's the one place you can get hung up right there. If you don't put it there, all your information's wrong after that.
Did you put the 0?
Because we don't have an x squared. See how it skips from cube to x? That means there's a 0x squared there. Yes? All right, now the number on the outside, I can do 1 or negative 1. I'll just start with 1. And now we work quickly through this. So 0 here, add down, multiply, 1 here, add down 1, multiply 1. Is this going to work? No. Negative 20. Not quite. Almost, right? It almost worked? It almost worked, but it didn't. So
Maybe it's a negative 1.
maybe it's negative 1. So that's what I would tell you to do next. Don't do 1, 2, 3, 4, 5, 6, don't do 1, 2, 4, 5, 10, 20, and then come back and do negatives. Do 1, negative 1, then 2, negative 2, then 4, negative 4. Okay, 1, 0, negative 21, negative 20. 1 here, negative 1, negative 1, positive 1, negative 20. There you go. Positive 20, there you go. Works. That's what we wanted, right? So this is where last class I said, what our ultimate goal last class I said was to be able to read this table, and this table would tell us the answer as far as how that factors. Do you remember what I look at?
Yeah.
What do I do? What do I do with this piece? What does that tell me?
It's gonna be X.
That'll tell me x plus 1 is a factor. It's the opposite, okay? Be careful with that. Then these three numbers are the remaining polynomial. And it will be 1 in front of x to what power? 2. So 1x squared. Why is it x squared?
Because we went down by an X.
You just look at this power that you started with, and it will always be 1 less than what you started with. So this will be 1x squared minus x minus 20. All right? Questions?
So if it was just x squared, it'd just be x.
Yes, if it was x squared, it would just be x. If it was x to the 5th, then that would be x to the 4th.
You would have put 1, just put negative x,
You-
factor squared.
You could put a 1 in here, and you could put a 1 out here if you wanted to, but normally we don't write them, right? Like usually you don't put a 1 in front of x squared, even though we all know it's there, right?
Do we need to factor that out?
Now, okay, so now here's what we're saying. We're saying at this point that we know that this actually turns out to be x plus 1 times x squared minus x minus 20. Our hope is that we can now break this down, right? But that's something I would expect everyone here could do, right? Can you break that down? That's x minus 5 plus 4. There we go. And that's just knowing what we know about factoring quadratics and something we've been told you should be able to do, right? We good?
Yep.
That's it. It's factored. We're done. And it happened on the second try, so that was nice. Let's do the next one. Yeah, let me do one more, and then maybe I'll let you.
Now, quick
Have
question.
at it. Yep.
You usually do it within, now you're,
I will.
in regards to your test, do you mean like the first 6 numbers, including positive or negative, or on your tests? Or?
Like, yeah, including positive. I think the most you'd ever have to do long division-wise would be like 8 divisions.
Okay.
Like if you find yourself like doing your 15th long division and nothing's happened, then something else is wrong. Like you wrote down your synthetic division incorrectly, or I accidentally made a typo on the test. No, I won't. I'll check it. Don't worry.
He's like, now we have to watch out for that. Sir, is there a typo?
When I was in graduate school, all of our exams were take home. So we had this exam. It was 2 problems. Is there a question? You all good? So, you all okay?
I was wondering if you were able to GCF it once you start.
Well, yeah. Let's talk. We're going to go through this step by step.
Okay.
Do y'all want to hear the rest of my story? I don't have to tell you. Okay. All right. That would have been funny if y'all were like, nah, just do the problem. We don't care.
Well, I was interested.
Are we
Are you
paying you
taking this?
Yeah, this isn't story time. We're not paying you to tell stories. No, but it was a take-home exam. It was 2 problems. We had like 4 weeks to do it, and it was our problem. So it was a problem that we had to prove this statement was true. So I went through and I couldn't prove it, but I was actually able to disprove it. Like I was actually able to come up with an example of something that proved that couldn't be true. So I found what we call a counterexample. And then I said, well, if these 2 numbers were different, then I could prove it. And then I went to go see the professor, and he was like in his office. This guy was like very unapproachable, like, like scary type of professor. So I walk in there, and he's just like bothered that I'm even there. And I'm like, sir, I'm just, I'm letting you know that on this problem that you gave the class, here's the problem, here's my counterexample, and if these 2 numbers were different, then this is the proof that would prove it. And I just sat there, and he goes, oh, that's a typo. He's like, those are supposed to be those other numbers. And he goes, tell the rest of the class. I was like, 3 weeks of my life I'm never getting back. But
Do you like extra credit or
I was like, do I get
hell no, he didn't give me anything for But it was actually, I probably learned more about that problem than I ever would have, because I actually had to like convince myself that it, like, there was no way I was wrong. I had to convince myself before I walked in to talk to him. You know, I had to be able to defend my own work. And that was probably more constructive than had the typo never been made. Anyway, okay. So, you wouldn't have told anyone?
Are you telling us something or what?
No. Okay, so the first thing here, we recognized the GCF, right? Ryan pointed that out. And you always want to go back and do what you know how to do, right? Take care of that to begin with. Did I get everything right? You agree? Okay. Now, don't forget this factor. It's out here, all right? Do not forget that it's there. And now we're working on just this. And this piece in here, there's no technique of factoring that you ever saw to handle that, right? But now we have some new method that could work. And I need to put a little asterisk there. It could work. This method does not always work. And we'll talk more about when it fails after we get through some examples. So let's just try it. We have a list that we're going to create, right? We have a 1 out here. What does that tell me right now that that's a 1?
That your first list is going
My first list is my final list, right? So do I really need to make all the lists?
And it's always
No.
a whole number.
Yep. So let's try it. My final list are all the factors of 10, which there aren't many. That's it, right? 1, 2, 5, 10. And then I'm going to create my synthetic division. And I'm going to go to town on this thing. Let's see. 1, -3, -11, 3, and 10. And I'm going to start with 1. And hope for the best. Am I going to get lucky on my first try? I doubt it. Oh. So I'm very happy about that. I'm happy about that. So I'd like for you to tell me now what that says this is equal to.
X minus 1.
X squared out here, right? I'm rewriting this x squared, and then all of this in parentheses is x minus 1, and then this right here is
X to the third.
x to the third, 2x squared minus
And then minus
10. There we go. With that, yeah, I'm going to put that back up here. Okay, remember now, the third came from the fact that we were working on this piece in here, right? It's not a 5, okay, because we'd already pulled the x squared out. You good? So I'm going to say that this whole thing turns out to be x squared, then the x minus 1, then x cubed minus 2x squared minus 13x minus 10. That's where we are now. Now you look at this and you ask yourself, can I factor that? Maybe grouping, because it's 4 terms, so you'd split it right there. It's not going to work. So if grouping doesn't work, what other method do we have?
Would the grouping not work on any of that we use?
No, it could. It could, yeah.
You just know that.
Well, I guess so, yeah. If I pull out, here I pull out x squared, right? So I'd have x squared and then x minus 2. Over here, I'd have to pull out something to get an x minus 2 in here, wouldn't I? And I'm not going to be able to. So usually, the way I recognize grouping is that somehow these numbers and these numbers have to be like multiples of each other. So like if this were a, I don't know, a 3 and a 6, it might work.
And then if you saw that and it would work, then
Yes, do it. Yeah, definitely. If it would work by grouping, go ahead and do it that way.
So do we do that again?
That's
Yeah, so the question now is what do you do?
do it
Right?
again.
Start the whole process over,
Yeah.
make a new list. Well, it actually turns out that the list you had, you can keep working off that list.
Yeah,
You don't have to
still
create a
the
new
same
one.
10 and-
It's coming off the same polynomial. But there's one catch to this. If you're going to use the same list, all right, then when you set up your new synthetic division, which would be what? 1, -2, -13, -10. When you do this, you need to start where you left off, even if it worked. So 1 worked, right? That does not mean I should now start at -1. I need to go back and check 1 again because 1 could actually happen more than one time. It could turn out, we don't know yet, it could turn out that this right here is x minus 1 and then let's say x plus 7. It could, and then something else. It could turn out that you have x minus 1 again, like a repeated factor. So squared, exactly. So we have to check 1 again. Understand? Let's say though that we had, see it worked on the first try. Let's say we did, see if you can keep up with this. Let's say we did 1 and it didn't work, okay? We did -1, it didn't work. We did 2, it did work. Then we come over here, where would I start? At 2. You don't have to do 1 and -1. So you don't have to start back at the beginning, you just have to start where you left off. Okay? Because if 1 was going to work, it was going to work in the beginning. It won't all of a sudden work now when it didn't work before.
Okay, it's kind of like when you're regular dividing. It's like if 2's not going to work.
If
then
2 doesn't go into
if I do
15,
it again,
right? Then yeah, it's not. Then when you break down 15 to 5 and 3, 2 is not going to go into 5 or 3.
So we would start then with -1.
Yeah, I'm going to start here with 1 right now. Even though 1 worked, I'm going to do 1 again and see if it works. So 1, -1, 1. I don't think this is going to work. Wow, that was like a perfect sounding, like you know when people say like people sneeze, it sounds like hachu. That was a perfect hachu. You're welcome. That didn't work, right? Go back, y'all can watch the video later. That sounded, maybe you didn't hear it over there, but that was a perfect sneeze, if I've ever heard one. All right, where am I going to go now? If 1 doesn't work, -1, okay? So now, I know some of you have seen this before, maybe, I don't know. You've seen maybe the synthetic division. Sometimes it's taught where what you do is you just continue working a new synthetic division off the bottom of this. I'm not going to do that because I want everyone to understand that what we're doing is every single step that this works, I'm creating a new version of the polynomial every single step. Okay, so that didn't work. I've got to go through and draw another box and do all this stuff again. And I'm going to try -1. It does work? No? Doesn't? Okay, so we have some conflicting opinions here. Let's see. -1. Drop down, we get 1. -1 is -3. That's 3. That's -10. That's 10. That's 0. It does work. Got it? Now, this tells me that I have a factor of x plus 1, right? And then what's in here? X squared, good. Minus 3x minus 10. So now I'll go back and rewrite the polynomial. I'm back over here. Right, this right here becomes x squared, x minus 1, then x plus 1, x squared minus 3x minus 10, right? That's where I am now. This right here is a quadratic, and I think I can factor that one.
Yes, you
x minus 5 plus 2?
Yes.
All right. So when are we done? Like now, right? Once everything's down to linear factors, we are done.
At some point, are you gonna ask us to plot that?
Yes. The test problem that you're going to get will just be sketch this polynomial.
And then we have to break it down and then.
Yeah, so look, now if I asked you to sketch this, this wouldn't be that hard, would it? Look, you've got, which way does this open? Up, up, right? Up, up like this. Then you'd go find the x-intercepts. Where are they? Right here. So you have x-intercepts at 0, 1,
Negative 1.
-1, 5,
And
-2. It goes up here, it goes up here, crosses everywhere,
All touch except for right 0 to 0.
all cross except at 0 it touches. So it's going to go like this.
Sorry, I got them mixed up.
That's it.
It would have been
That's your graph.
two exact
You see?
opposites, but-
Too difficult for me.
I mean, does this seem pretty reasonable to you? I mean, there's plenty of room for mistakes, right, on the little division and stuff. But when in the grand scheme of things,
This is a fair question.
we've actually come pretty far. If we call this function f of x as this is a 6th degree polynomial, and you would think that that would be pretty hard to graph that, like quickly. We can probably graph that within 10 minutes. You know, if we work quickly, we can probably get a graph of that in 10 minutes. So it's that step where you say, what are the x-intercepts? That step's either going to be easy or it's going to require this, synthetic division and all that stuff. So that's what will be on the test.
It's fair.
Yeah. Okay.
I think this is easier than some of the other stuff that we do.
Yeah, actually, like, in a sense.
Yeah, because you know it's all one topic as opposed to
But the other
the other
was
stuff
a
we
lot
were
of
spread
broad-
out everywhere.
broad
Yeah,
things.
I agree. Okay, you want to try 5? Or 5. Do you want to try D?
Sure.
Why don't you try and sketch D? Try and draw me the graph of D. Yeah, I'll write it up here.
All of this stuff is kind of building off of each other, so it's much easier to remember.
So you're trying to sketch and I'm hoping that this one, I haven't worked this problem out recently, so I'm hoping that this one's not going to present a new weird issue. But you go ahead and get started on that. And I will check it real quick. Yeah, it works out nice. Okay, we're about 9 minutes, 8 minutes in. What are you thinking? How many of you think you got the graph? Yeah?
I have a little, I think I got this one.
Okay.
I think I got it.
Think you got it?
How about me?
I mean, I don't have it written say that, but it sounds
Well, then that one makes, my graph makes so much more sense now. It does, weird.
it's -2 twice.
Yeah. Yeah.
Okay, the curve is around that, it takes 2 a second
Yeah.
time.
What number worked first? One worked? Forgot the zero in the long division?
Yeah.
Uh-oh. Yeah, that's going to cause major problems. Were none of them working?
It works on one,
It does?
but nothing's removed.
Yeah.
Yeah, I had to go all the way to negative 2. I mean, 2.
Your second list -2 works.
To the third. So what worked on the second one? -2 was the next one to work?
Making us try like 4 different things at the hydrometry. Just kidding.
I put 3.
So did you do -2?
I got a negative,
But that's after you factor that. You get down to quadratic.
maybe I made a mistake that it didn't work for me, and I went on to.
Then you went on, okay, so that's okay. We should all still get the same answer.
I mean, I got the same thing.
Yeah.
Well, yeah. It's just, I got the 3 out of after I got the.
Yeah, either way, it's like.
It's the same thing, but.
Because when I factored at the end, I got 2.
One of these.
All right. Are y'all getting this? Yes.
Okay, you don't have to add that 0.
Where?
Where you added it at the top, no, that one, on the second list.
What 0?
That's 0.
This, okay, this list right here, this is coming from this, which is your answer. See, when you take this and break down your polynomial, this gives you x minus 1 as a factor right here. And then this is x cubed plus x minus 8x minus 12. Okay, those are the numbers that go in your next list. You don't go back to the original. Yeah, go to these numbers now.
And then would you put the x squared?
Yeah, so at this point, once you've got everything put together here, you want to combine any common factors together because that's going to tell you whether or not you cross or touch. Exactly. So you have to do x minus 1. I'll do the x plus 2 now. X plus 2 squared, x minus 3.
So then you get 0, 1,
1, negative 2, and 3.
3.
That's
And
right.
then it'd be cross, touch, and cross.
That's it.
I got it right.
That's it.
I got it
Yeah,
right.
good. Anyone else have a question on this? I'm going to draw it now. Yes?
So even though the 9, you still gotta bring x squared down?
What x squared?
On the top, after, when you pull the x, you have the x before, the next one, see how 9 just went away, but you still bring the x squared with it? You see what I'm saying?
What x squared, though?
Like x cubed plus x squared minus 8x minus 12?
Yeah, what we're saying is that this right here, right? This piece right here, we did right here with our synthetic. This one tells us x minus 1 is a factor, and then these 4 numbers, right? So that becomes this piece right here.
I mean, I can see why they just need to.
Right? The x minus 1 comes from this. 1, 1, negative 8, negative 12 is this right here. Okay? And then on my next step, what I'm doing is I'm breaking just this one down. And that's this piece right here. And that one comes down x plus 2. And then these numbers give me the rest. That's this piece right here. You following? Yeah. And then on my last step, hey, I've got another color. I'm breaking just this down, but that I did just by knowing how to factor a quadratic. Understand that? Okay. Yeah, and then on the bottom I just combine the not like terms, we would say that we just combine the factors together. So let's just draw the graph real quick. So the x-intercepts are 0, 1, negative 2, and 3. I will touch here, cross here, and touch here because the powers, right? Powers on the factors. Okay.
Supposed to touch at the 0 too?
Yes, touch at 0 also. So 1.
I thought it was cross. I thought it was, no, wait.
Wait, I'm sorry.
I was like, hold on, no.
Y'all are trying to y'all are trying to confuse me. All right, so it goes down on the left.
It's a typo, guys. Don't worry about it.
Yeah, tell everyone, please. Go tell everyone. All right, so that's what it looks like, right?
So we're going to do the opposite of what you said down there?
Yeah.
So we're going to.
We're gonna
Cross, mute,
touch
right?
that.
Oh, sorry. Oh, this is all backwards. Sorry. Okay. Cross, cross, touch, cross. Yes. All right. So cross through, no touch.
Then cross. Cross.
There we go.
So it would have gone down and then up if you did touch, cross, touch, but I mean, you would have got the wrong track.
There we go. Okay. That's the idea. That's the idea.
Okay,
Yep.
now let's do F.
You want to do F?
Yes.
Okay.
School bus going across it, that's what we're doing.
We'll do F together, and then after we do F, I'll give you one to try.
No kidding, right? Especially if you're building a bridge. Don't screw up. The soccer mom just built the bridge.
Just remember, school bus is testing out the integrity of your bridge.
Two.
And they're on their way to a field trip. They are in a hurry.
To help the four children.
Is that what it is?
Yeah, that's what you're gonna get.
Okay, here we go. We'll go through the whole process of sketching it. So we're going to sketch it. We're going to look at it as a function of x. And it's going to be negative 2x cubed plus 3x squared plus 17x. Is her name Angie? No, Andy? Abby. Get with Abby on the sneezing thing. She's got that down. All right. How does this open?
It's gonna go like
Oh,
this.
no, this way, this way, this way.
Up on the left, down on the right.
There you go.
Up, down, right? Up, down. Can't remember that? You know what x cubed looks like?
The opposite.
Probably.
All right. Well,
Negative x.
yeah.
You'll probably get it.
X squared, all right?
Negative.
X cubed, and then negative x cubed. All right, that's done. X-intercepts. So we need to set this equal to 0. Negative 2x cubed plus 3x squared plus 17x minus 30 equals 0. GCF? No. 4 terms.
Can't group it.
Can't group it. It's not going to work with grouping. Right? Not going to work? So let's look at the list. Now, this is the first time that we actually have something other than 1 out front. So we're going to have we're going to have to pay attention to this. Our first list,
1, 2, 3, 5, 6, 7, 8, 9, 10.
plus or minus 1, plus or minus 2, plus or minus 3. 4 doesn't go into 30, right? 5 goes into 30. 6 times 10, 15. Now, I'm just making the list real quick, but if you were doing it yourself, you would probably work maybe from the outside in. I don't know how you would do it. But can I trust that you can get that list? Okay. Then my second list is going to be all the factors of 2. So 1 and 2. Positive and negative 1, positive, negative 2. My final list now. All right, if I take every single number here over 1, then I just get this list up here, right? So I've got that list first. But then, in addition to that, I have every one of these over 2. So what's 1 over 2? 1/2? Plus or minus 1/2? All right. What's 2 over 2? 1, I already have 1 in my list, don't I? So I don't have to write it again. 3 over 2 is not in my list, so 3/2. 5 over 2, not in my list, so I'm going to have to add it. 6 over 2 is 3. I've got that in my list. 10 over 2 is 5. I've got that in my list. 15 over 2, not in my list, so I need to put it here. 30 over 2, 15, I have it. That's my new list. Questions on where that came from? No?
Should we start with whole numbers?
Okay, so now the question is, if I told you to, put them in order, then if you put these in order, the smallest one is actually 1/2, isn't it?
Yeah.
But what I'm going to say is same thing. Start with whole numbers and work your way up. All right? For the test, I'll make sure that at least one of these whole numbers works. But like in the real world type situation, you would actually need to be prepared to go through the whole list if you had to. Just for time's sake, I'm assuring you it'll happen like sooner than later. So we go through, we try 1. It doesn't work. We try 2. Try -1. It doesn't work. We try 2. It's going to work. So I'm skipping the ones that don't work, and I'm just going to tell you what does. All right? So understand that we've gone through 1 and -1. And so I'm going to put 2 out here on this. Be careful. This first number is -2, isn't it? Then 3, then 17, then -30. So on this first one, the -2 comes down. You get -4 here, add down -1. You get -2 here, you get 15, and then you get 30, and then you get your 0.
Wow, we managed to solve that in our first try.
Yeah.
Oh, we did it.
So look, here's where we are now. This equation, right, for my x-intercepts, this equation, I can factor it using the factors x minus 2 and then whatever these 3 are. So -2 what? X squared
Minus x plus 15.
minus x plus 15. So here's where I am. I'm at x minus 2, -2x squared minus x plus 15 equals 0.
And then that would become x minus 6 and x plus 5.
No, that won't work.
Oh, yeah.
Yeah, you got to have a -2, so what could you do? If
No, that works then. X minus 6, x plus 5. Doesn't that work?
mm,
Or would that
Go
work?
ahead and do it.
You can start where you left off.
The first multiplication there is x squared. You don't have x squared.
Well, it's wrong,
Right.
yeah, you have to have two.
You have to have negative 2. Okay, so look, here's the deal. Remember I said that, we could have taught this method from the beginning, right? Like when you were learning how to factor. You have a quadratic. That's not necessarily simple to factor. It does, though, it does factor, okay? It does. So what you could do is you could actually just do synthetic division on this thing, just using the same list that you were working with. So if I were going to do synthetic division right now,
Start back with two.
I start back with 2, right? And I'm working on this.
Are we always going to be able to reference that same list?
Yes. Yes.
So we don't have to make up a new list.
Nope, that's right. You just go off your same list. Just make sure you pick up where you left off. So I would try 2 here, wouldn't I? I'll just do it just to show you. It's not going to work. But -2, -4, get -5, and then I get -10. That's 5. That doesn't work, right? So what would I use next? No, remember, I already said when I did this that I was cheating. I did 1 and -1 already.
So whatever doesn't work on that,
Is not going to work here.
so like we crossed out 4 on the first.
That's right. We were ready on our list, which isn't up here. I didn't show you, but these 2 didn't work. Okay? 2 was the first one that worked. I tried 2 again. It didn't work. So now I'd move on to what? -2. So do this again with -2. You wind up like filling up your page with a bunch of synthetic divisions that don't work.
I noticed.
So I'm doing -2 out here. Did not work. So that didn't work. So what will we move on to next? 3. Doesn't work. So we're starting to lose faith in this. -3 is going to work. Okay, so 3 doesn't work, so I move on to -3. Finally, it worked. Now, what does that tell me? X plus 3. Now be careful here. X plus 3,
-2x
-2x plus 5.
And then you still have.
That was just this piece, right? That's what we just broke down. This right here is been broken down with the synthetic division to be this. And now I'm going to get my final, this version right here, my final thing, so I can get my x-intercepts. So I have x minus 2, and then x plus 3, and then -2x plus 5 equals 0. That's it. That's the way it breaks down, yeah? Now set each of these equal to 0. You get 2, -3. This one's a little more involved, right? You just set it to 0, move things around, solve for x. You should get what? 5 halves, right? 5/2. What am I going to do at each of those intercepts? Cross or touch? What do you think? They all cross? Cross, 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 because 1, 1, 1. Now we just got to make sure we get those on the x-axis in the right places. I think 2 and -3 are easy to put on there, but where's 5 halves? 2.5. So if you need to go on your calculator to figure out where this is, then go. No, because you're taking -2x plus 5 and you're asking yourself, when is that equal to 0? So you move the 5 over, and then you divide by negative. Negative over negative becomes positive. We good?
Yeah, for some reason I wrote -2x minus 5.
Oh, okay, I see.
That's fine.
So this is 2.5. So I'm going to go like this. -3, +2, 2.5. We don't need to be like really, really accurate with this, right? We've already kind of given up on trying to figure out how high things go and low things go, so we don't need to be real precise with our x-axis either. Just make sure that you don't put like -3 on the other side of 2 over there, right? Okay, so it goes up on the left and then down on the right. Like, it's happened before, trust me. It's happened. Okay, so I'm going to cross through, and come back. That's it.
Really easy to do.
All right, so did this die? What's up? Oh, there we go. Wow, I'm all the way back at the beginning. How'd that happen? So a summary is that basically we've found another way to factor, right? This is a very powerful technique. It has limitations though, and I do want to talk about some of its limitations, and I also want to give you at least what this is called, all right? What you're doing when you're creating this list, notice that when we have our list, our final list, right? Notice that in that final list, you're always going to have like, I don't know, 1s and maybe 2s in there, right? You might get something like 5 halves. All of these numbers in here are all going to be a certain type of number. They're called rational numbers. Now, we need to discuss briefly, hopefully I'll keep it brief. What are rational numbers?
Numbers that are not imaginary.
Okay, good. Imaginary numbers are not rational numbers.
Everything else.
Everything else
No. Rational numbers are fractions.
Oh,
are fractions, ratios.
Everything else is not like, it's not an endless decimal.
Okay, so let's be clear on this. There's a couple of sets of numbers we should just make sure we're all comfortable with. We have what are called the natural numbers. And we use a double struck capital N. Sometimes they strike it across the N like this. Double struck capital N. This is all your natural numbers. This is 1, 2, 3, forever.
So negative infinity, positive infinity?
Nope.
No, it's
Nope.
one-
Just
it's
1, 2,
2,
3. Keep counting. Those are your natural numbers. 1 to infinity, but not
numbers in between them.
nothing between them. Okay, so 1.5 is not in the natural numbers. It's just like when you're teaching a kid in first grade how to count, right? They have no idea what like 1.3276 is. Same thing here. 1, 2, 3, 4, 5, right? These are called our natural numbers. Then we have the whole numbers. Well, you know what? I'll move past that. Let's just go to integers.